Hello again. Um, in this particular module, we'll be talking about the analysis of mutually exclusive alternatives and in particular incremental analysis. Incremental analysis is the one legitimate way that you can use the internal rate of return in your analysis. So we'll be covering that in this particular video. I'm inside today. I would be outside, but the temperature seems to get to the computer a whole lot quicker than it does to me. So it's 102 out there right now, headed for a high of 111. While I'll be enjoying the heat later, my computer is enjoying the cool inside the house. So here we go. If you would, please open the modules spreadsheet and go to the second sheet, Module 2, and we'll be covering this particular problem. It's the same problem that we looked at in the last video, but for this problem we'll be using a different solution procedure, and that is incremental analysis. So let's look at the problem. We have again three alternatives. We'll select the best of the three. Again, I've just repeated what I did before to start. We have all the data for the problem, for the alternatives, and I have calculated the rate of return for each one, and we find again that for alternative B the rate of return is less than the MAR, and we're going to eliminate alternative B. We'll get there in a minute. So let's go through the individual steps, and for each of these incremental analysis problems you should follow these same steps, and if you are a stickler and disciplined about following the steps, the order of the steps, I think everything will work out okay for you. Step one again is to find the proper interest rate, to get the proper interest rate to use for the problem. I won't go into any more detail than that here. Suffice it to say that we will be using 12% for our interest rate for this problem. Step two is where we determine the base alternative, and that is we will order these by increasing initial investment. The smallest initial investment, the rest of the cash flows are irrelevant for this part. The smallest initial investment is the base alternative, and that would be alternative B. Since alternative B has already been eliminated, it's already not an acceptable alternative, then we eliminate it from consideration, and our base alternative then is alternative A. We can go down to the second table that I've constructed. So I've gone from alternative A to alternative C, alternative A being, again, the base alternative. We know that alternative A is acceptable. The IRR was greater than the MAR. We could have found the present worth of A, which we did in the previous video, the previous worksheet here in this particular spreadsheet. And we could have, we can tell from that that alternative A is acceptable. So alternative A is already a winner. Alternative C is the next largest initial investment. If we had many alternatives, again, these would be rank ordered in terms of initial investment, increasing initial investment. The next one in this problem is alternative C. And what we will do, notice I've added a new column to the table, and this column is alternative C minus alternative A. Here's the concept. We know that alternative A is good. We know it's an investment that we would like to make. Now the question is, if we had $15,000 more to invest, so we have more money, what should we do with that $15,000? Should we, A, invest in alternative A and then take those $15,000 extra dollars and invest them in some other alternative, let's say at the MAR. So we would have $85,000 in A, $15,000 invested at the MAR, or should we take that extra $15,000 and instead of investing in A, invest in C? So the last column you see there, alternative C minus alternative A, shows the incremental cash flows. That is the additional investment required to go to alternative C, and the additional income, the additional cash flows that you get by that investment in alternative C. So these are all incremental cash flows. This is what you would do, the change you would make to invest in alternative C. The question is, does this additional investment in C and the additional returns in C warrant making that move? Is the additional initial investment recovered sufficiently by the additional revenue? Another way to say that is the rate of return on the additional cash flows sufficient to warrant making the jump from alternative A to alternative C? Well, step 5 here is to determine if the incremental cash flows meet the investment criterion. So we look at those incremental cash flows just like another project, if you will. We analyze it in just the same way. I found the rate of return of those incremental investments. We could have calculated the present worth of the incremental cash flows and see if the present worth was positive at the MAR. But for this problem, I used the internal rate of return, and you can see in the table the internal rate of return is 10.69%. That's less than the MAR. Remember, we're not comparing that return to anything other than the MAR. And since that rate of return is less than the MAR, what that tells us is that instead of investing the additional $15,000 in alternative C, which would have yielded us 10.7% return on all those incremental cash flows, I would rather invest that $15,000 at the MAR and earn 12%. So earn 10.7% or earn 12%. I'll take the 12%, thank you. And therefore, investing in C is not a good move. Alternative A is the winner. That is, this is a head-to-head competition. Alternative C versus Alternative A. Alternative C lost. Alternative A won. So we eliminate Alternative C. Alternative A remains. One last point to make in this sort of problem is the note I have at the bottom of the worksheet. And that is, we can use this same process for cost alternatives. That may not register quite yet, but even if all of your costs, everything is a cost and you have no income, in general, when you invest more in an alternative, you will have reduced costs. So you might invest more money up front, and it may result in lower maintenance costs, less frequent rebuilds, whatever the case may be. And if you take lower costs minus higher costs, you get positive cash flow. So you can even use this technique with cost alternatives, and that incremental investment from one alternative to the next will actually show an extra investment at the top and positive incremental cash flows further down, so you can still find a rate of return, or you can find a positive present worth if it's a good step to make that incremental investment. So we can use this for investment alternatives, we can use it for cost alternatives. Let me say that you'll notice that going through this incremental analysis, our decision was alternative A. From the Module 1, we noticed, looking at the present worth, that our decision was alternative A. And in fact, you will get exactly the same decision using what we talked about in the last video, using present worth or future worth or annual worth, or using incremental cash flows, incremental analysis. You will come up with the same alternative being the preferred alternative no matter which of these methods you use. So you might be asking yourself, well, so why do we do the incremental analysis? We do it not so much for the decision, but two reasons: for the defense of the decision, and because of the additional information that we might now have available because we went through the incremental analysis. Sometimes when you're making these decisions, it is good to know what the effects of those incremental cash flows are, and that incremental rate of return is a useful number in either defending your particular project or marketing your particular project over against another alternative. And that's why incremental analysis also works. In the next module, we will begin to look at unequal-lived alternatives. And that is where the alternatives that we're considering may have different lives for each alternative. Now realize that we need the same length of service in order to compare alternatives. They have to be comparable, right? They have to deliver the same product or service, and they have to be for the same period of time. So that presents a challenge to us, but we'll address the challenge in a pretty straightforward way, and we'll talk about that in the next module.